we will take a look at function templates here. Consider the simple function printIt in the sample code. So here we have the code for our printIt function. It takes two integers as parameters, so we have a and b. Inside of this function, we declare an integer c, which is the sum of a and b, and then we print a, b, and c out to the terminal. Now inside of main, we are going to experiment with some different function calls and see what happens. We also have a declaration for two string variables. We'll come back to that in a moment. What I want to focus on here is that we have a function call to print it where we pass it two integers. Then we have a function call passing two floating values. And then we have a function call passing two characters. So you might be wondering, well, the data types in printIt are integers, but we're trying to pass it other data types. And that's what we want to experiment with here. So in the terminal, we can compile and run our code and see what happens here. So when we call printIt and we pass it two integers, it works the way that we want it to. It says, you gave me 1 and 2. Together, they make 3. That looks good. When we pass printIt to floating values, this is where we start to notice a few problems coming into play. So printIt only takes integers. So the floating point numbers 2.6 and 3.7 became coerced to integers. It says you gave me 2 and 3. It got rid of the decimal value, it truncated it. And now together 2 and 3 make 5, but what we were expecting here is a value of 6.3. Similarly, notice how the character version is printing out ASCII values instead of the characters. And it says that together they make 114. If we try to pass it strings, this will not work in this program. There is no good coercion for the string type to integer, so the program won't compile if you try to use it. And I'll just demonstrate this here. So again, there is no good coercion for the string type to an integer, so the program won't compile if we try to pass printIt to strings. We can fix all these problems by making printIt generic with templates. The idea is you want this printIt function to handle all those different data types, including integers, doubles, characters, and strings. So we want to use the keywords template and type name. So in this templated version of printIt, we are going to have this line of code where we say template, and then angle bracket, type name, t, and then a closing angle bracket. The keywords template and type name are used here. The t becomes a generic type or a placeholder type. Now you can use any variable name instead of t here. And what the compiler is going to do is it will generate the different versions according to the data types sent to the function when called in main. So we can write one templated version of printIt using our placeholder t. So here we have two parameters in this list, and they are of the type t. And the compiler will generate new versions of this function depending on what data types we want to substitute the t with. And then inside we can use this placeholder as well. So we are typically saying that c equals a plus b, and this variable c can also be of the type t, this placeholder value. And then the function will print out a, b, and c like before. So now we have this templated version of printIt, and again the compiler will generate the different versions according to the data types sent to the function when called in main. So we have one templated function here, and this can work with multiple data types. So now that we've seen the templated version of printIt, let's add this in here. Let's template the printIt function. So I have my placeholder t, and I'm going to replace the integer type with this placeholder. So maybe a will be a double or a character now. This placeholder will be very convenient. So now this function is templated, and the compiler will generate different versions of this function depending on the data types that we need this to work with. The template type name t becomes part of the printIt function. So it's as if this is a part of the function's name. When we look at our main function, we have 4 function calls to printIt. So how many versions of printit will be generated by the compiler? 4, because we have 4 different data types that we want to use. So now in the terminal, this was our previous output where this was not working with different data types. I'm going to clear this up and compile again. So now looking at the output here, it works the way that we want it to. If we give it 2 integers, 1 and 2, together they make 3, that looks good. If we give it 2 floating values, 2.6 and 3.7, that gives us a value of 6.3. If we give it 2 characters, A and 1, the ASCII values are added together and converted back to a character, so together they make R. And if we give it 2 strings, O and Nose, together that makes O Nose. So now you should see what happened here. A new version of printit is generated for each data type used as a parameter. Notice though that operations on the data types are bound by the normal rules that apply to them. The string concatenation would not work for C strings, and the behavior shown by the characters is a little odd. So now we will discuss a few notes on the syntax. This line of code, template type name T, can be on the same line as the function type declaration, but it is usually on the line above. The value T stands for the type the template will be instantiated with, so T could be replaced with integer, double, so on. T can be any valid token, but watch out for namespace clashes. T's scope is limited to just one function, so in this case, printit. Now notice that we don't need to do anything special to make printit work for new types. If a placeholder appears more than once in a function's parameter list, the types you use in their place in the function call must match. So recall that printit takes 2 parameters of this T placeholder type that we're using. So if I have integers A and B and a double C, it is okay for me to call printit and pass it the 2 integers because that data type matches here. If I try to call printit and it's expecting the same type coming in, I cannot pass it an integer and a double because those data types do not match and the compiler will complain. So you want to be very careful that if a placeholder appears more than once in a function's parameter list, the types you use in their place must match. To create a prototype for a templated function, remember to include the template specifier like so. Again, this can be on the line above the function prototype or on the same line, either way is fine there. I just want to emphasize that the prototype for the function needs this template, type name, and whatever name you are giving your placeholder.